Okay, can you hear me, everybody?
No, it's
Sorry,
not.
madam.
Yes.
Okay, today actually I have uploaded one exercise file on partial derivative. So today I will actually try to solve, okay, the exercise. Okay, so the first exercise, okay, it is about actually, that marginal utility. Okay, do you know anything about the marginal utility? Do you know anything about huh? Do you know anything about marginal utility? What is called marginal utility? Okay, actually, marginal utility, okay. You know what is utility?
Madam, is it satisfaction?
Yeah, utility means happiness or satisfaction when you are consuming anything, okay. Utility means, happiness or satisfaction when you are consuming any product or any service. So that means the marginal utility, it will indicate change in, total utility divided by change in X. Okay, so that X indicate, like X and Y, it indicate the number of product. Okay, so now since, last class we discussed that we are now discussing about the bivariate function. Bivariate function means the dependent variable, it depends on two independent variable. So here in this exercise, you can see that the utility, it is the function of X and Y. So utility is the function of X and Y. So that means U indicate utility. Okay, utility. Okay, utility, it is actually here dependent variable. And the utility, it depends on two independent variable. One is X, another one is Y. So X and Y indicate the, like the number of, number of product X and Y. So now that means you see that utility, if it is a dependent variable, it depends on two independent variable. One is the number of X, another one number of Y. So now in this case, when we calculate the marginal utility, okay, in that case, it will be two marginal utility. One will be with respect to X, another one marginal utility with respect to Y. So when we calculate marginal utility, okay, with respect to X, in that case, it will indicate change in total utility divided by change in X. But here, Y is constant. And when we calculate the marginal utility of Y, then it will indicate change in total utility divided by change in Y. Here, X is constant. Okay, do you understand, everybody? What is marginal utility of X and what is marginal utility of Y? So that means when we do with respect to X, then Y is constant. We cannot change the number of Y. And when we calculate marginal utility with respect to X, Y, then X is constant. So we cannot change the, the X. Okay, so now calculate the marginal utility if the, utility function here. Okay, utility function U is equal to minus 4x9 and y to the power 4. So here utility function is equal to minus 4x to the power 9 y to the power 4. So now you have to calculate. The question is, if suppose this is the utility function, you have to calculate marginal utility of x, that means delta u by delta x, and the marginal utility of y, that is delta u by delta y. So that means you have to calculate marginal utility of x and marginal utility of y. So it will be delta u by delta x when marginal utility of x. So now y is constant. Okay, so you have to remember the rule of differentiation. Why? When it is the rule of like constant times function. So if y is constant, so that means it will be like 4 and y to the power 4 will be constant. Then multiply, you have to find the derivative of x to the power 9. So it will be 9, then x to the power 9 minus 1 is 8. So that means 4 times 9 is 36. Then x to the power 8, y to the power 4. So that is the marginal utility, with respect to x. Similarly, we can calculate marginal utility with respect to y. Now x is constant. You have to remember now that x is constant. So it will be, okay, now you see that x is constant. So that means, sorry, here it will be minus. I forget to write down the minus. Okay, so now it will be minus 4x to the power 9 is constant. Only you have to find the derivative of y to the power 4. So it will be 4 y to the power 4 minus 1 is 3. So it will be minus 16 x to the power 9 y to the power 3. Do you understand, everybody? Is it clear, everybody?
Yes.
Okay, so now we go to the next question. Question number 2. Okay, here question number 2 is saying, okay, hold on. It is about, I think, marginal productivity. So this is also you need to know what is actually marginal productivity. Okay, first you see that here this is the production function, okay, Q. Q is equal to 65 k to the power 1 by 3 L to the power 2 by 3. So now this is called Cobb-Douglas production function. Okay, Cobb-Douglas production function. What is this function? This function is saying that, okay, the production of any product, okay, it depends on, this is called capital and labor. So that means the production of any product, it depends on two things. One is capital, another one labor. But here you have to assume that other things are constant, because not only capital and labor can affect the production. There are number of things that can affect the production. For example, weather, okay, or there is like producers expectation, different thing actually can affect the production of any product. But here we assume that other things remain constant, then the production of any product, it depends on capital and labor. Okay, so this is called the Cobb-Douglas production function. Now you have to calculate delta Q by delta K. What is this one actually? This is called marginal productivity of capital. Marginal productivity of capital. And also you have to calculate delta Q by delta L. What is this one? This is called marginal productivity of labor. Okay, now you see that here, what do you mean by marginal productivity of capital? Actually, it indicates, like we write down this way, marginal productivity of capital, MPK. Okay, it is actually change in total production, okay, change in total production divided by change in capital. But L is constant. Okay, what does this mean? This means that if we change, K 1 unit, then how much total production is changed. Total production is changed, holding L as constant. Like you don't change L or labor, okay? But you change capital 1 unit, then how much change in the total production? That is called marginal productivity of capital. Similarly, this one, delta Q by delta L, we call it marginal productivity of labor. That is called change in total production divided by change in labor. But here K is constant. So what is this one? This is called if we change, labor, okay, 1 unit, how much change in the, how much total production change, how much total production is change holding K as constant. So that is called the marginal productivity of labor. So you have to understand the, the concept, like what actually we mean by this, marginal productivity of labor and marginal productivity of capital. Now let's do this exercise. Okay, here it is saying that suppose that the output of a certain company, that means the Q, it is equal to 65 K to the power 1 by 3 and L to the power 2 by 3, where K is the capital in thousand of dollar and L is the number of labor. Find the delta Q by delta K, that means marginal productivity of capital, and delta Q by delta L, marginal productivity of labor, when capital expenditure are 20,000 and labor hours total, for 4,594. Okay, so now let us do this one first. Q is equal to 65 K to the power 1 by 3 L to the power 2 by 3. So now you have to calculate delta Q by delta K. So now L is constant, right? Because we are doing it with respect to capital. So L is constant. So that means 65 L to the power 2 by 3, it is constant. Then multiply, you have to find the derivative of K to the power 1 by 3. So you bring 1 by 3 in front, then K to the power 1 by 3 minus 1. So it will be, okay, 65 divided by 3, okay. Then K to the power 1 by 3 minus 1 is, minus, 2 by 3. Then L to the power 2 by 3. So that will be your answer. So now you have to substitute 65 by 3 like capital, which is, $20,000. But you here, since we are saying that this is in thousand of dollar, so you can write down capital as only 20. You do not need to write down the whole 20,000 because it is in thousands of dollar. Minus 2 by 3 and L is 4594 to the power 2 by 3. Now find out the answer. How much the answer?
Madam,
Yes?
why you substitutes here?
Because they are saying that you have to calculate delta Q by delta K, delta Q by delta L when capital is this one, labor is this one. So that's why you have to substitute and we have to find out delta Q by delta K, this value. Do you understand?
Yes, madam.
Okay, so now everybody please calculate.
$812.64.
Eh? 12.64.
812.64.
Okay, the answer is, what is the answer? Did you get anybody?
Madam, I get 808.32.
808.32.
But
And then,
someone get difference. Let me check again, madam.
Madam, I get 812.64.
yeah, the answer, it is the correct answer. 812.64. Yeah, the answer is 812.64. That is the correct answer. Do you get anyone?
Madam,
Okay,
Madam?
try to, yes,
why do you substitute 20 instead of 20,000?
because it is mentioned that the capital expenditure, it is in thousand of dollar. That's why you do not need to substitute 20,000. You can substitute it in like 20 because it is mentioned already that it is thousand of dollars. So if you write down 20, it indicate 20,000.
Okay,
For me, I
Yes? Hello?
How about the labor hour?
Huh? Because this one
stated
already
for
is in the number of labor hours. So the total number of labor hour is this one already because it is in the number of labor hours. So 4,594, it will be, the hour, 4,594 hour. So you do not need to write down like in
oh, I
short.
thought.
Yeah. So, but don't worry, in the exam, I don't give you like not so like this one, okay? Because it is, I just mentioned you that it indicate K the capital, L is the labor, okay? So you,
Madam,
and
you put 20 as the expenditure, capital expenditure, but it is 20,000.
yeah.
But on the other hand, you put whole figure as hour.
Because it is the
So
mention like number of labor hour. So that means this indicate 4,594 hour
madam,
already. It is,
if the expenditure is like 200,000, so what we will take? 200.
yeah, we have to take 200. We have to take 200. Okay, so now similarly, you have to calculate delta Q by delta L. Okay, so calculate it. Try to calculate. So here it will be 65. K to the power 1 by 3 will be constant. Only have to, differentiate L to the power 3 by 2. So you bring 2 by 3, then L to the power 2 by 3 minus 1. So it will be 65 by 3, K to the power 1 by 3, L to the power, it will be minus 1 by 3. Okay, now you substitute all the value here. K is 20 to the power 1 by 3. L is 4594 to the power minus 1 by 3. So now find out the answer. Okay, I am posting your like the attendance after 5 minutes. You just check your attendance form in the Google class, and you just, or I'm sending it to your WhatsApp group. Okay, after 5 minutes, you just now calculate this value. Okay, about your final exam, please be careful. Okay, I will send you the link in the Google class. Okay, and you have to, you have to submit your answer there. Don't send it to my email. I cannot accept it because this is the Kulia rule. Okay, so I cannot do anything. And remember, final is 50%. So you will be totally fail. I cannot do anything. So I'm telling you in the class already many times. Please take it serious, okay?
Excuse me, madam.
Yes.
Shouldn't 65 be times with 2? Because 65, 2 over 3.
Hold on. Just hold on. I am doing your attendance. I send it, then I will tell you, okay? Just give me few minutes. Hold on. Okay, I am trying to send it to your WhatsApp group, the attendance. Okay, I think better I send it to your Google class, okay? Hold on. Okay, I have uploaded this, that means your that exercise file. Please try to do the exercise, whatever the exercise I do. You always try to solve all the exercise. If there is any question that you cannot answer, okay, please you let me know. But no, until now nobody you try to do any, I don't know, you just don't tell me anything. Yes.
Madam, we are used attendance, so I didn't see.
What?
So I mean, we are have attendance.
No, I'm sending you. Please check your Google class, okay? After the class, okay?
Okay.
You just now we go back to the okay, after the class I already posted on the attendance. Okay, you just go to Google class and there is one topic, attendance. Okay, so you will find today's attendance form. So after the class, please submit your attendance. Okay, now what is the answer? Just now somebody asked me some question like 65 by 3. Okay, there is 1 2, right? Okay, 2 multiplied. I'm sorry, I made mistake here. So it will be 130 divided by 3, right? Then 20 to the power 1 by 3. Then 4594 to the power minus 1 by 3. Now, am I right?
Yes.
Okay. So what is the answer, your answer? Can you tell me?
0.7.08.
Hmm?
7.08.
The answer is 7.08. Do you get the same answer? 7.08. That is the answer. Okay. Do you get the same answer?
No, madam.
Yes. Yes,
Yes.
madam.
Okay, so who didn't get, please you check. Okay, now the next question, number 3. Okay, now we are doing the question number 3. Okay, I will you try to do it all the exercise today. Because I cannot do all the exercise. Okay, I cannot finish all. So whatever the exercise will be left, if you try to do next, today. But next class, I will discuss optimization of the bivariate function. Okay, now you see that. Can you see question number 3? Okay, so now you see that this is the joint cost for two products. Okay, remember that last time when we do like the optimization of the cost function, or like, for example, can you remember cost minimization or profit maximization? That time the dependent variable, for example, cost or the profit, it depends on only one independent variable, that is the number of product X, or the number of price of only one product. But here the cost functions, for example, here it depends on two product. One is X, another one is Y. That's why that is called bivariate function, and that is why we call it joint cost function. But remember that in some exercise we will give you differently, like separate cost function. One is, for example, C1, another one is C2. For example, the C1 is the cost function of X, and C2 is the cost function of Y. So in that case, what we have to do, we have to find out the joint cost function. That means we have to add these two cost function and we will get the joint cost function. But in this case, you already given the joint cost function. You do not need to, add. But sometimes in some exercise, we will give you the cost function for X and Y separately. Then what you have to do? In the beginning, you have to first add these two cost function and you will get that is called joint, cost function. Similarly, sometimes we will give you separately, for example, the demand equation P1 and P2. Suppose the demand equation, this is for X and this is the Y. So if you want to find out, for example, the total revenue function, total revenue, in this case, total revenue will be two. One is for X, R1, another one is R2. So since here you are given P1 and Px, so we can get R1, which is price time quantity, and R2, which is P2 price time quantity. So the total revenue, TR, it will be R1 plus R2. So R1 will be P1X and R2 will be P2Y. So this is just I am telling you, because sometimes you are not given joint revenue function, joint cost function. You will be given separately. So don't confuse, okay? You have to add and you have to get the total cost function or total, revenue function. So now let us do this exercise. Here you see that this is the joint cost function, okay? We write down first CXY is equal to 15, plus X square plus Y plus 5XY. Now, where X represent the quantity of product X and Y represent quantity of product Y. You have to find the marginal cost with respect to X if 20 units of product X and 90 units of product Y are produced. That means if X is equal to 20, Y is equal to 19, then you have to calculate the marginal cost with respect to X. So now calculating marginal cost with respect to X, actually it indicates how much change in the total cost divided by change in X, but Y is constant. You don't, change the Y is constant. Then what is the change in the total cost? If you change X 1 unit, that is called marginal cost with respect to X. So now, since Y is constant, so you have to consider it as a constant number. So the derivative of 15 is 0. The derivative of X square is 2X. Derivative of Y is 0 because this is constant number. Now the derivative of 5XY, you write down first the constant number, then multiply the derivative of X, which is 1. So it will be 2X plus 5Y. Now you have to substitute X equal to 20 and Y is equal to 19. So it will be 40 plus 95, right? So 5, then 135. Am I right? The answer is right? 135. Yes. So how to interpret the result? If suppose you get marginal cost with respect to X is 195. How do you interpret your result? Because sometimes I will ask you to interpret. So if marginal cost with respect to X is 195, how to interpret that? If we increase, X 1 unit, the total cost will be increased by 195 ringgit or $195, okay, holding you know, y, y constant, or you have to write down holding y is equal to, because can you remember y value how much? Y is 19. So you don't need to change the y like 19, holding y equal to 19 as constant. Like you have to produce 90 unit of the product, 90 unit of y, only you increase x 1 unit. Okay, that means you have to increase x 1 unit, but y you produce still 19 unit. You don't, change, increase or decrease, y. You still produce y 19 unit, only you increase x 1 unit, then the total cost will be increased by how much? 195. That means this is actually additional cost. Okay, additional cost for one more unit of x. That means if you produce x one more unit, then you have to be an additional 195 ringgit. Okay, so that is called the marginal cost with respect to x. Is there any question? Okay, now question number, I think I go to question number 5. Okay, so question number 5, because the question number 4 I think you can do. Okay, so now we can.
Madam.
Yes.
Why we don't need to do the marginal cost? Why?
Yeah, you of course you can do, but here I didn't ask you to do. Yeah, if you are asked to do, you just follow the same way. But remember that you have to hold the x as constant. Do you understand, everybody? When you do with respect to y, then x will be constant. That is only the difference. I didn't ask you, but you can, of course, if you are asked, you have to do it. Okay, now this is another question, I think question number 5. Okay, if the joint cost function, okay, it is like cxy, it is 9 minus 9x to the power 4 to the power y to the power 7 minus 3. So this is called the joint cost function for two products. Now we have to find out marginal cost with respect to y. Okay, so now do it. You know that here you just make it simple first, like y to the power 7 minus 3 to the power half. Okay, here you see that you have which, when you do the differentiation, you have to follow which rule? Okay, I show you. You have to find marginal cost with respect to y, right? So that means x is constant. X is constant. So you can write down this is as the constant number, minus 9 x to the power 4 is constant. Only you have to differentiate this one. So you follow which rule? Power of the function rule. Can you remember it? Suppose y is the function of x, it has the power n. So how to find the derivative? Dy by dx. It will be to bring the power in front, write down the function to the power n minus 1 to the power, multiply the derivative of the function. So that is the power of the function rule. So you follow the rule, you bring half in front, write down y to the power 7 minus 3, then to the power half minus 1 is minus half, then multiply the derivative of that function. So the derivative of that function will be 7 y to the power 6, and the derivative of 3 is 0. So it will be 7 y to the power 6. Now you just write down it. 7 times 9 is 63. Okay, x to the power 4, y to the power 6 divided by 2, then y to the power 7 minus 3 to the power minus half. Okay, so That is called marginal cost with respect to y. Is it clear, everybody?
Yes, ma'am.
Or you can just make it simple like that. You can do like this: 63 x to the power 4 y to the power 6, then 2 root this one divided by 2 root y to the power 7 minus 3, because this has power minus half. We can write down 1 by root y to the power 7 minus 3. So that is the answer. Okay, now if there is no question, I can, yes?
What if I leave the answer without simplify? I just leave it the final.
Yeah, you don't, no problem, you can get the answer. You can get the mark.
Okay.
I only want to see whether you follow the rule or not. But remember, I'm just all time I just reminding you, please follow your link when I ask you to submit your final exam paper. This one very serious. Please take it serious, because this will go to Kulia. I cannot do anything. You have to maintain. Okay, so now, and you know that your final exam is 11 January, right? Do you know?
Yes, madam.
And it will be what time?
2:30.
2:30 to 5:30.
Okay, 5:30. So I will
Just
ask
2 hours.
you, yeah? I will give you 4
2 hours
questions.
only.
Answer all questions.
We have
And
to turn on our camera, madam.
yeah, you have to turn on your camera. And remember that you have to join the Google class. Okay. And then I will share the question on the slide. And you have to submit your answer to the Google class. Okay, now this is another question. Suppose this is the joint, joint cost function. Okay, so CXY is equal to 1,500 ln XY plus 1 plus 15,000. Okay, you have to find the marginal cost with respect to X. So it will be Cx, that means Y now constant. So here you have to follow the rule of the log function. Can you remember how to do the? So it is, suppose fx is the ln, suppose y is the ln fx. How to find the derivative of this function? Dy by dx. It will be f prime x divided by fx, right? So this is the rule of the log function. So you follow the rule. So 1,500, it is constant, times you have to find the derivative of that function. So in that case, here fx, fxy, it is actually xy plus 1. So now here fx, because you are doing it with respect to x, y is constant. So y times the derivative of x is 1. So it will be y, because the derivative of 1 is 0. Okay, so here f prime x, it will be y, and then fx, it will be xy plus 1. And the derivative of 15,000 is 0. So the answer will be 1500 y divided by xy plus 1. Okay, now if suppose I tell you that x is equal to 2 and y is equal to 1, calculate Cx. So you substitute x equal to 2 and y equal to 1 into this, marginal cost. So it will be 1500 multiply y is 1 and 1 x is 2, then times 1 plus 1. So it will be 1500 divided by 2 plus 1 is 3. So it is 500. So how to interpret the result? The interpretation will be, if we increase x 1 unit, the total cost will be increased by 500 ringgit, holding y as constant. So if we increase x 1 unit, okay, total cost will be increased by increased by 500 ringgit, holding y as constant. So that is called the marginal cost with respect to x. Now let us go to the next question.
Madam,
Yes.
the answer says marginal cost. Find the marginal cost, but
Yeah.
you put CX.
Yeah, this is called marginal cost. If you write down MCX, also you can write down. Okay, better I think MC. Okay. Sometimes we write down CX also. Okay, that will indicate marginal cost. Okay, so now another thing that you need to learn, that is called the product, like, okay, I give you one example here. Okay, hold on. Okay, but I think this one you learn from the economics, that that is called that competitive product and the complementary product. Okay, first we write down, okay, here this is the topic about competitive and complementary product. Complementary product. Okay, so suppose QA, okay, this is called demand function for product A. It is the function of price of product A and also price of product B. Okay, this is called demand function for product A, because you know that the demand, okay, for any product, it does not only depend on its own price. Sometimes it also affected by the price of other product. I will give you example later. And also this is the demand function.
Madam, what is QA?
QA is the quantity of product A. QA, it is called quantity demanded of product A. Like how much people they will purchase the product A, it depends on the price of product A and also the price of product B. And this is called quantity of product B. Quantity demanded of product, okay, B. That means how much people will buy product B. It depends on the price of product A and also price of product B. Okay, that is the rule. Like when you purchase some product, you go to the shop, you find that the same quality, the two products, but one is cheaper than another one. Which one you will buy? The same quality, almost same quality. Suppose you want to buy a phone, but you find that there are two, like suppose two brands, but they almost the same quality. So which one you will purchase? Which one is the cheaper one? Because if they maintain the same quality, why will buy the expensive one? So that's why the price of the quantity of any product, it not only depend on its own price. Sometimes it also affected by price of other product. For example, coffee and tea. if the price of coffee go up, okay, what happened to the quantity of tea? Because if you find that coffee is expensive, now you will drink more tea. So the quantity of tea will be increased, or demand of tea will be increased because coffee is expensive now. If suppose the the price of coffee decrease, then people will buy more coffee because now tea is expensive. So quantity of tea, it will go down because now coffee is cheaper. So people will buy more coffee than tea. So this kind of product, we call it competitive, because they, because the almost the quality sometimes it is, but they are also exceptional because sometimes people, they are so addicted by coffee. Although the price of coffee increase, they cannot avoid it, still they drink coffee. So this is different. Suppose some people, they are not so addicted, so then they shift it to another product. For example, another one is the the paste. One is suppose Colgate, another one is the suppose the suppose Spark,
Pepsodent.
or yeah, Pepsodent. So if suppose Colgate price go up, then this one will the quantity of this Spark or the Pepsodent, suppose it is increased. So that is actually, that means the Colgate and the Spark, they call competitive. Another, there are also some product, for example, tea and milk. Suppose some people, they cannot drink tea without milk. So if the price of milk go up, the tea, the quantity of tea, it will go down. Because why? Some people, they cannot drink tea without milk. So if the price of milk go up, so they reduce the drinking of tea. So they don't drink so much tea. So it will go down. Or suppose for camera, okay, you need what? Maybe now they use pen drive or some what is called the camera. For camera, they need suppose now they need chips or something, right? They use. If that price increase, go up, then the demand for camera go down. People nowadays, they don't use so much camera, okay, because now the mobile phone, they are competing with the camera, okay, they shift to mobile phone. So that's why the demand for camera go down. So, or the chips of like the camera, what they use for taking the photo, it price go up, the demand for camera go down. So that is called complementary product. Complementary product. Or suppose the fuel. If fuel price go up, the demand for car, okay, it is go down. People use public transportation. They don't use the private car. They use public transport. So that's why the private car, its demand go down if the price of fuel go up. Or people, they don't travel so much, so they just use the public transportation. So this kind of product, we call it complementary. Okay, now using suppose the demand for function for product A and B, we can actually determine whether the product is competitive or the complementary. Okay, I show you how we can determine. Okay, here you see that if okay, but before that you need to know, okay, you need to know that is called the marginal demand for product A, okay, with respect to price of product A. For example, that is called delta QA divided by delta PA. That is called marginal marginal demand for product A with respect to price of product A. What does this indicate? This indicates that what is the change in the quantity of product A if the price of product A increase 1 unit. That is called marginal demand for product A with respect to price of product A. Now, this is called delta QA divided by delta PB. That is called marginal, marginal demand for product A, okay, with respect to price of product B. Okay, that is called marginal demand for product A with respect to price of product B. Another one, delta QB divided by delta PA. That is called marginal, demand for product B, okay, with respect to price of product A. Another one, delta QB divided by delta PB. So that is called marginal demand, okay, marginal demand for product B, okay, with respect to price of product B. Again, I am telling you what is called marginal demand for product A with respect to price of product A. What is this one? This one called like how much change in the demand for product A if the price of product A increase or decrease 1 unit. So that is called the marginal demand for product A with respect to price of product A. Another one, marginal demand for product A with respect to price of product B. That means it indicates how much change in the quantity of product A if the price of product B increase or decrease 1 unit. Okay, so that is called marginal demand for product A with respect to price of product B. And similarly, this one, like how much change in the demand for product B when there is change in 1 unit change in price of product A. Okay, similarly this one, how much change in the quantity of product B if there is 1 unit change in price of product B. So when you calculate this one, like marginal demand for product A and B with respect to price of product A and B, okay, and the sign of the this marginal demand will determine whether the product A and B, they are competitive or they are complementary. For example, if delta QA by delta PB is both of them, okay, they are positive. What does this mean? This means that, for example, this one, delta QA by delta PB. Okay, what if it is positive? What does this mean? This means that if price of product B increase, quantity of product A also increase. So, and what is this one? If price of product A increase, quantity of product A increase. So that means A and B, they are competitive. For example, just now I mentioned to you, coffee price increase, the quantity of tea, okay, also increase. So they are competitive. So that's why when these two, marginal demand of product A with respect to price of product B and price of product A, both of them are positive, then A and B, they are competitive. Then if suppose the marginal demand of product A with respect to price of product B is like negative, delta QA, sorry, delta QB. I'm sorry, this will be del QB, delta QB. Okay, I'm sorry. This one will be PB increase QA, and if PA increase, QB increase. Okay. So this will be delta QB. Okay, I'm sorry. So this will be positive. Here delta QA by delta PB less than 0. Delta QB by delta PA, it is less than 0. What does this mean? This means that if price of product B increase, then the quantity of product A will be decreased. Or if price of product A increase, quantity of product B, decrease. So that means A and B complementary, because the relationship is like negative. So that means A and B is complementary. Okay, and if suppose both of them, okay, and then if you find that the A and B, they don't have any relationship, when this thing happen, like here you see that delta QA and delta PB, one is positive, another one is negative. Then, like AB competitive, or this one, positive, this one negative, then they are complementary. But AB, like they don't follow the, like the same way. Okay, I will show you later. Like here, they one is positive, another one negative. Like here you see both of them are positive, both of them are negative. But when AB, they don't have relationship, that means one will be positive, another one will be negative. But here in this case, when both of them are positive or both of them are negative, then they are complementary, and when positive, competitive. But when you find that one is positive, like delta QA by delta PB, suppose you get positive, but this one you get negative. Okay, or suppose this one you get negative and this one you get positive. So in that case, A, B, they don't have any relationship. Okay, so I show you the example. Here, I think this is the exercise that we have to do. This is question number 8. Okay, we will see from this exercise whether A and B, they are competitive or they are complementary. So now you see that the first equation, this is called the demand function of product A, and this is the demand function of product B. Okay, so now the question is, okay, you have to, find the marginal demand. Okay, so that is the question, marginal demand of product A and B. Okay, what is the question? The question is, find the marginal demand of product A with respect to price of product B, and the marginal demand of product B with respect to price of product A. Then after you find, you have to determine whether the two products are competitive or complementary. So first we find marginal demand of product A with respect to price of product B. That means delta QA by delta PB. So that means you have to differentiate this equation, the demand function for product A with respect to price of product B. So now when we are differentiating this equation with respect to price of product B, that means PA is constant, price of product A is constant. Okay, if PA is constant, So the derivative of this one is 0. The derivative of 40 PA also will be 0 because PA is constant. Only we have to differentiate this one. So 200 by PB minus 4, we can follow the quotient rule. So first write down PB minus 4, then multiply the derivative of 200 is 0. Then minus, you write down this one, 200. Then multiply the derivative of PB minus 4, which is 1. Because the derivative of PB is 1 and the derivative of 4 is 0. Then divided by PB minus 4 is equal, to the whole square. So now, here it will be 0 because this one times 0 is 0. So minus 200 divided by PB minus 4 whole square. So that means this value is less than 0. Why? Because this one has negative sign. So now you have to, secondly, you have to calculate marginal demand of product B with respect to price of product A. So that means you have to calculate delta QB divided by delta PA. Okay, so it will be here. Okay, here you see that we have to differentiate this equation with respect to price of product A. That means PB will be constant. Okay, PB will be constant. So if PB is constant, so that means this part is 0 because this is a constant number. This part will be also 0 because all are constant. Because here we are assuming PB is constant. Only I have to differentiate this one. Okay, so now it will be minus. Okay, now you have to follow the quotient rule like PA minus 5 times with the derivative of 300 is 0 minus, you write down 300, the derivative of PA minus 5, it will be 1. Because the derivative of PA is 1 and the derivative of 5 is 0. Divided by PA minus 5 whole square. Now it will be, negative 300 and here also minus. So minus minus become plus. So 300 divided by PA minus 5. So it is positive. Now you go to the rule, like when we will find this one. Like here you see that delta QA by delta, like we get delta QA by delta PB is negative, delta QB by delta PA is positive. So delta QA by delta PB we get negative. Okay, and then delta QB by delta PA we get positive. So can you tell me whether A and B is competitive or complementary? First, you try to understand this one. It has, negative. So that means if PB is increased, price of product B, then QA will be decreased. And what it is positive. So if PA is increased, QB is increased. So what they are they complementary, competitive, or okay, what will be your answer? Can you tell me?
Neither.
Huh?
Neither of them.
Okay, it will be because they are not maintaining any relationship. Okay, so that means A and B, they are not competitive, they are not complementary, because they don't go the same way. Like it should be this one should be also positive, or this one also should be negative. So one is positive, one is negative. So that means A and B, they are not complementary, they are not competitive, because they don't have they don't follow the same kind of relationship. So that means A and B, they are not complementary, or they are not competitive. That means they don't have any relationship. Okay, is it clear to you?
Yes.
Okay, now we can do another one. Okay. I think there's today this one is the last question. Okay. Everybody, did you give your attendance? Okay, if you don't give now, you just give it after the class. Okay, now you see that this is the demand function for product A of product A, and this is the demand function of product B. Find the marginal demand of product A with respect to PB, marginal demand of product B with respect to PA. And then you have to find out whether they are complementary or competitive. So we can do like delta QA by delta PB. It is, this will be 0, and this will be for delta PB, right? So this one will also 0 because PA is constant. And here it will be PB minus 4 times the derivative of 200 is 0 minus 200, then the derivative of this one will be 1. Okay, and then this one will be 0, right? So 200 times 1, and then PB minus 4 whole square. So it will be minus 200 PB minus 4 whole square. And then you have to find out the marginal demand of product B with respect to price of product A. Delta QB by delta PA. So it will be, this will be 0. Now PB is constant, so this part will be also 0, and this part will be minus PA minus 5, then the derivative of 300 is 0 minus minus this one, right? So you have to write down 300, the derivative of PA minus 5 is 1, divided by PA minus 5 whole square. So it will be plus PA minus 5 whole square. So one is negative, another one is positive. So, okay, so here you see if like the same thing, okay, okay, so I think here actually, what do you mean by PB is increased quantity of product B is, since it is negative, so it will be decreased. And if PA is increased, quantity of product B also increase. Okay, so if one, I think they are not, they do not have a relationship. Okay, because one is negative, another one is positive. Okay, so I think that's all for today. Okay, next class, actually, we will discuss the optimization of the bivariate function. Okay, before I leave, is there any question you want to ask me?
Madam,
Yes.
How do we know whether it is more than 0 or less than 0?
Because it is showing negative sign and positive sign from there.
Oh, okay, okay.
Yeah.
Madam, for delta, we have to differentiate.
Yes, delta.
Madam, can you explain on delta QA over delta PB?
Delta QA over delta PB. Okay, hold on.
The last slide.
Okay, hold on. Delta QA by delta PB.
Yes.
Because it is negative, so that means if price of product B increase, quantity of product A will be decreased because they have in that means this one is less than 0. If it is less than 0, it indicate that if price of product B increase, quantity of product A will be decreased, or price of product B decrease, quantity of product A will be increased. So that means it indicates that A and B, they have, like competitive, right? And this one is positive, so that means PA is increased, quantity of product B also increased. So that means they don't, the A and B, they are not related, because they are showing different, one is negative, another one positive, so they are not actually, they don't have actually relationship. If they have to show negative, or they have to show positive. If they show negative, both of the marginal demand, they will be complementary. If both of them show positive, in that case that will be competitive. Okay, both of the marginal demand of product A and B with respect to PB and PA, both of them should show the same sign. If positive, then competitive. If negative, then complementary. Do you understand?
Yes, madam. Thank you.
Okay. I think that's all for today, right? So next class we discuss optimization of the bivariate function. I think, okay, we end the class today now.
Madam,
Yes?
Madam, I text you about my quiz 1 and 2 in WhatsApp, but you didn't see my message.
Okay, I will check later.
Okay, I will text you after the class again.
No, I will actually, when I finish marking quiz 3, I will send you, I will check all the message that you send, and then I will update the Excel file and I will send it to you, okay, when I finish marking quiz 3. Then you check again your quiz 1 and 2 mark. Until that time, please wait, okay? Because I cannot message, there are so many messages, I cannot answer all. You just wait until I mark quiz 3, and I will update the Excel file in the Google Classroom, so you can check. If there is still problem, let me know.
Okay, madam, thank you.
But I will take note all of your mess. I will see. But remember that if you don't submit it in the link, this time, okay, maybe I accept, but I have to reduce your mark, 10% mark. Didn't send it to the link. But then for the final and for especially the final, I don't have any way to accept it. Okay, so please be serious about it. I think that's all for today.
Madam,
Yeah.
So far we don't have assignment, right?
Hmm?
So we don't have assignment, right?
Assignment, I'm not sure yet. Maybe I will give on the, because this is 12 week, right? Maybe in the 10th week, but I will let you know. Don't worry.
Okay, thank you very much, madam.
Okay, so assalamualaikum everybody. Okay.
Okay.
Madam,
Yes.
I didn't get my result for quiz 1 and 2.
Why? Because I already sent it to you. Okay, I will.
Madam.
Yes.
Madam, I have some problem in my quiz 1 and quiz 2 result. So I me to. So what should I do?
That's why I'm telling you, just wait. I will update the Excel file again. Then you let me know, okay?
Madam,
Okay, thank you, madam.
Okay.
Madam,
Yes.
yeah, we have only 3 quizzes, right?
Yeah.
We have only 3 quizzes, right?
Until now 3. I will take another one. That will be the last quiz.
All right, okay.
Okay. Okay. Bye. Assalamualaikum.
Bye.
Waalaikumsalam.